Okay, so I failed to record this part of the lesson on Friday, so I'm doing this separately for you online kids. But it's really quick. It's just going to review how fossils are made. So on Friday, we talked about how sedimentary rock is made in 5 different stages. Don't look at this right now, but in 5 different stages. The first stage would be sediment. What's going on? Hold on a second. Let me see if it's. I think it's moving forward on its own. Maybe not. Okay. Anyway, first step would be weathering. Those rocks are broken down into smaller pieces. Step 2 is erosion, when those small pieces are carried away by water, wind, ice, gravity. Step 3 is deposition, when those pieces get dropped off somewhere else. Step 4 is compaction and cementation, when the pieces are pressed together as well as glued together by the matrix, whatever matrix may be, silica, calcite, sometimes even just water with other minerals in it. And then step 5, after compaction and cementation, we have the new sedimentary rock. So that's what you're seeing on this screen here, okay? It says after compaction and cementation, the sedimentary sequence has changed into a sedimentary rock. Sedimentary rocks like sandstone, shale, and limestone differ from other rocks in that they, number 1, are formed from layers of sediment that have built up over many years. We talked about how the word sediment is literally in the word sedimentary rock, so that means it must be a rock made of sediments. Number 2, grains of sediment cemented together by various minerals. And number 3, here's what we're going to pick up today. These aren't your notes, by the way. Number 3, they may contain fossils, remains of plants and animals that were caught up in the sediment. Okay? So we're talking about how that happens. Okay? Here you can see the different layers of the rock. Okay? I think you guys can see my pointer here, but you can see kind of a lighter layer and maybe a darker layer, maybe kind of an orange layer, etc. But this video is a really good job showing you the different layers that build up over time. Now, the thing with sedimentary rocks is these are the kinds of rocks that can form fossils, like what you see in the pictures at the top. Sometimes, as the sediments are being deposited, the remains of plants or animals, or what become fossils, are found in sedimentary rock because they were caught up in the sediment during the forming of the rock. Okay, I'm going to do my best to draw for you guys what I drew in class. Okay, so let's pretend we have some mountains here. Okay, and we have a little river flowing down the mountain that dumps into a lake or a pond. Okay, alright, cool. So at the bottom of this pond we have fishy. Okay, so fish is swimming at the bottom of the lake, and one day there's a really bad storm, and there's a huge lightning strike that hits the mountains. Okay, completely hypothetical. I'm totally making this up. Now, after the lightning strikes the mountain, it causes a landslide. Okay, and let's pretend that all of these rocks, these huge, sometimes even huge, sometimes smaller sediments, begin rolling down the hill, and fishy has no idea what's coming, right? Now, eventually, these sediments are going to fall on top of fishy, okay, and he's going to be killed from the impact. It's kind of a rough day for fishy, okay, but those sediments are going to build up on top of him. Now, his body has not decomposed yet, right? He hasn't really had time. He just died a second ago, okay? But as those sediments begin to build up over top of fishy, alright, the imprint of his body is left in the sediments of the rock. Kind of like Play-Doh, okay? If you had Play-Doh or clay in your hands and you wanted to make an imprint of something, you would press it into the Play-Doh and then remove the object, okay? Well, that's kind of what happens here with the fossils. If the fish is covered up by sediments before it decomposes, then as the sediments harden and form into a rock, the fish will so dissolve or decompose away. Okay, his body will break back down into dust or dirt. But the rock will have hardened before that can happen. So the imprint of his body is left in the rock. So that's what you're seeing up here. This is an extinct animal, but the imprint was left in the rock here and here. Okay? So that's how we get the definition for a fossil. A fossil is defined as any remains, trace or imprint of a plant or animal that has been preserved in Earth's crust during prehistoric times. Technically, to have a true fossil, it's supposed to be something that was alive during prehistoric times, think like dinosaurs and things like that. But you could sort of make your own fossil with some people do it with cement or plaster of Paris, even clay models can have fossils or imprints in them, but technically a true fossil, a natural fossil, takes many years to form. Now, the thing about fossils, and part of what makes them so rare, is conditions have to be just right for fossilization to occur, okay? Going back to the example of fishy, if the fish were to decompose before being covered up by the rock sediments, then he just becomes part of the new rock. His body pieces have broken right down into dirt, and it just becomes part of the new sediments of the new rock. But if the plant or animal dies and the sediments quickly bury the remains before decomposition erases all evidence of the organism's presence, then the imprint will be left in the rock. So it has to happen pretty quickly, and then it has to be left for a long period of time. That's part of the reason why they're so rare and so hard to find, and people get so excited about them. So, when looking at sedimentary rocks, it's kind of like each layer of sedimentary rock is a record or story of the past. Not all, but some layers have fossils in them. Scientists can look at the fossils in the rock they were found in and learn, number one, how old is that fossil? Okay, through carbon dating and different processes, they can figure out how old that rock is. Second thing they can figure out is what kinds of species lived in this place long ago. Okay, if you have a fossilized remains, of a zebra or something, then that means there must have been a zebra in that area at one time. And then, was there a lake, river, or ocean here? I'll come back to this slide. Pause if you need to, but I'm going to go back and use the picture for the explanation here. Okay, so here's the sedimentary rock I was showing you guys earlier. Okay, let's pretend that archaeologists are working in this area and they find a fossil of a fish. Let's pretend it's fishy in this layer. Okay, and they find a fossil of an oak tree up here in this layer. Wow, that's a really bad oak leaf, but let's pretend that's an oak leaf. Okay, now what does that tell you about this area? Well, in order for there to be a fish fossil over here, okay, that means there must have been a lake or a river or a pond or an ocean or something with water nearby at one time. Now, looking at the picture, there's no evidence of a water area now, but at some point there had to have been water here in order for a fish fossil to end up here, okay? Because the fish was caught up in the layers right here in this part of the rock. Then over here, with the oak leaf, okay, I'm drawing a little arrow here. I realize what I'm saying here, you guys don't know what I'm talking about. But anyways, if an oak leaf is found in the layer of the rock, couple layers up or whatever, looking at this area, the ground here, does this look like the kind of area that would be able to grow an oak leaf? Or an oak tree? No. It's way too dry, way too kind of barren. There are some plants here, but they're more shorter shrubs. Certainly not enough water and nutrients to grow a big tall plant like an oak tree. So if you find an oak tree in that layer, it must mean that at some point there had to have been enough water and nutrients for the oak tree to grow. Okay, that's kind of like how the rock layers and sedimentary rocks give a little bit of a story or a history of that area. Alright, and I think that might actually be it for these notes. Okay, there were a few videos here, but I'm actually going to have you skip those for now, and we're going to go on to this writing assignment. Fossil fuels we'll get into in the next few days as well, but this writing assignment is explained in the coming pages of the pod.